This is the final video in a Quest for Pi series, which will perhaps explore the most interesting method of the lot. This is a system with two separate blocks of two separate masses and two separate velocities. They are sliding on a frictionless surface, colliding against the wall and colliding against each other, where every collision is perfectly elastic. All this means is that the total kinetic energy of the system, as well as the total momentum before and after each collision, is the same. Let's consider the case where the two masses of both the blocks are equal, and the velocity of the smaller block is 0, and the velocity of the larger block is -1. The reason for the minus is so the block will move to the left instead of the right. We can count the total number of collisions in this system, so let's do that. The total number of collisions comes out to be 3. Let's consider another case. This case has the same velocities as before, but now the larger block has a mass 100 times the size of the smaller block. I won't animate this, but it's the same process as before, just with more collisions. A collision here does not cause the large block to stop. Instead, it slows and still moves to the left. When the small block hits the wall and collides again with the large block is slowed again. Whilst the process of hitting the wall and slowing the large block will continue. Eventually, the large block will start moving to the right again, and after enough collisions, it will go towards infinity, off the screen, at a faster rate than the small block can reach it. This means that no more collisions are bound to happen, and in this particular case, there would have been 31 total collisions. These are the two cases that we've already seen. Where the large mass and the small mass are equal, the number of collisions is 3. And where the large mass is 100 times that of the small mass, the number of collisions is 31. So let's have a look at other cases. What about if the large mass is 10,000 times that of the small mass? Then the number of collisions is 314. And there is a pattern. The large mass keeps going up by a factor of times 100. The next scenario, the number of collisions is 3,141, and then it's 31,415, and 314,159. Do you notice a pattern? Well, the collisions are actually counting the digits of pi. When the large mass is some power of 100 times that of the small mass, then the collisions will count pi. This is weird and not intuitive at all, as pi does not usually count things, but the proof is there and it requires deep levels of understanding. This understanding can delve into phase diagrams and equations of a system with kinetic energy and momentum, but it's a fun look into something that most people would not expect. And this is the final video in this series, and thank you for watching.